Yeah, we're going to be talking about utility stuff and the energy transition and grids in general. So I think a lot of your questions are going to be answered after this wonderful panel. We have Michael Oshetski, the CEO of Micatu. We have Philip Nevels, the Director of Corporate Strategy from AES. And we have Benedict Vergara, Ph.D. candidate in electrical engineering and a member of the SmartGrid laboratory here at George Washington University. Can we give him a round of applause? Okay, so again, I'm going to ask the question about what makes you so passionate. Would you pass that along to Michael, or? Oh, thank you. Sorry. There we go. Now we're all mic'd up. Yeah. Okay, yeah. So, what makes you so passionate about the work that you do, Michael?
Well, it's exciting times. You know, we have a lot of challenges in front of us, particularly about our consumption of resources. But what's make me so passionate about is, like, you know, these challenges we can face head on. We got brilliant people in multiple industries here. And I find it exciting that we can have the potential to leave a legacy, right? The legacy is that we solved a lot of tough problems, and a lot more tough problems we have to solve. But, you know, it's something of a time of change, and there's so much activity. And it's, as a technologist, you know, I want to leave a legacy for our children and our children's children that we actually tried. And, you know, maybe we're successful, maybe we're sort of successful, but that's the exciting part about it.
Thank you so much, Phil.
Good morning or afternoon. It's like incredibly bright up here. You guys have no idea. So what makes me passionate, well, I'm Phil. I work at AES, Director of Corporate Strategy there. Help us think about what our portfolio should look like across the world. We're a very diversified energy company. We've got gas assets, we've got coal assets, but our growth area is in renewables, utility scale renewables, storage, wind, solar. But what makes me passionate, and Michael touched on this, is climate change. You know, it is the you know, issue of our generation before us and after us. It is the major issue that we need to face. And given that our growth and our focus is on renewables, a lot of our effort is in growing renewables, and so we feel like we're able to have a real impact on what that looks like in a real sense every day.
Awesome, thank you. And Benedict, what makes you so passionate about what you do?
Hello, everyone. Thank you for having me. I, too, am a techno-optimist and naturalist. I battle that question every night when I stay up thinking about it. But I think one moment for me that got me into this was I was like 7 years old in New York City for the first time. And I was just observing this massive macro-organism that we've created out of just little parts doing their thing. And then that was the 2003 blackout. Don't do the math on how old I am because it's not fun. But that was a blackout that I was just shook. I couldn't believe everything that I was so in awe of just stopped completely, from like water pumping to elevators. And I think that because I was so young, it was like for sure what I have to study, resilient infrastructure. So when everything stops, when something like that happens, it makes you think about the lives that it could damage, and I've been doing research related to reliable, resilient infrastructure, power grids specifically, and now when we get into nature and equity, it's even more complicated. So that's what I'm all here about.
Wow, we have a great panel up here talking about mission critical stuff, right? People's lives are at stake. You know, we're talking about the future of our planet and how we move forward, and I think we're going to get into some really great discussions. So we've kind of touched on why things are so critical right now, but why is it so critical for utilities and cities to rethink their infrastructure needs from a grid perspective? Phil?
Oh, wow, I thought you were going to start with Mike.
Nope, we're going to mix it
yeah,
up.
So I mentioned the climate change. What I'll add to that are a couple things. One, we're at a time where, as we look at the technologies that are available to combat climate change, and I'm generally talking about renewables and, you know, including storage and wind and solar, and many of the technologies that are represented by the work that Michael's doing and others, we're seeing those come down in costs tremendously. And so there's an opportunity. We have the technology right in front of us right now to apply it to some of the problems that we're seeing. And so that should be cause for optimism. But at the same time, the way that, and speaking on behalf of utilities, the way that that system is set up in such a way as to impede our ability to integrate many of those things at scale and quickly. And that's we need to focus on that right now, because every moment that we're not focused on changing the system, we're the clock is running on climate change. So that's point number one. At the same time, I think it's so important for us to talk about and consider utility infrastructure specifically alongside city infrastructure, for the reason being that it's a system that we all pay for. So it's one of the few things that is truly socialized. We all pay for it. We split the cost of the system, some cases fairly, many cases unfairly. And so our ability to change that whole system impacts all of us financially. And so we need to think about solutions at a system scale together, because the way all these things work together and how they optimize and how they fit into one another impacts ultimately how much we're paying for this transition. So the idea is not only to make a transition of our economy, electrified economy, make a transition of our infrastructure, et cetera, but given what Brian said and others I'm sure have said, how do we do that affordably in a way that we're all able both to afford it and also able to take advantage of it at the same, right? So I think those are like the critical elements, like why this is something that we need to be talking about and focused on right now.
Thank you. And Michael, I think that you have a really interesting perspective on this. So from your perspective,
Yeah.
how do you think that utilities in cities, like, why is it so critical that they improve things?
Well, it's a great point. You brought up many of them. Is that the original infrastructure for utility grid is a very linear-based system, right? You go back to early 1900s. It's really, you had your power station, you have your transmission, sub-transmission, substations, and then that goes off into your communities. And really, what we're fundamentally changing to is a circular topology. What I mean by circular topology is DER is really starting to get integrated within various points of the utility, right? So this is a big challenge, is that we have an aging infrastructure where the original architecture wasn't designed to what we're trying to do. So, one of the things that I really see is that it's a multi-phase process, right? And we're evolving from a linear grid to a circular topology grid into what I see as the final be an integrated grid, right? And that's the challenge, is that we have to shift our thoughts fundamentally, not only from an infrastructure component, but also from us as a consumer, right? We are rising as prosumers in the utility of the future. And what I mean by that is that not only do we consume, we can also generate, we can also sell energy. So it's a very interesting structure that we have here, and there's many challenges in that, not only in socio-economic basis, right, but there's also regulation of this. And, you brought up a great point. We pay for the utility through our rate cases, right? So this infrastructure change is very important. And as we progress further and further into the city of the future, right, is that's the infrastructure level of the architecture has to change with it. So exciting stuff, right? But big challenges. And there's been examples of the integrated grid of the future. I don't know if anyone's familiar with the line in Saudi Arabia. I got the opportunity to meet some of the designers and architects of that. And it's just, what an incredible concept, yet what a mass piling of resources too. So there's a lot of challenges to try to get to that future grid. A lot of interesting solutions, so.
Absolutely. Thank you so much.
Yeah.
And Ben.
Wow, yeah. I think it's an honor to be talking here with both of you, because those are what we in the lab are doing every day. The puzzles, the problems we're solving are new, completely new. It's never before do you have research grants that are optimizing not only for cost, but for equity or emissions. This is new kind of money that's being put in to coordinate a grid that you describe, a grid that has bidirectional energy flow. And not only that, but your car can actually park somewhere else and help the grid in a different way. And just depending on where you park it, you could be helping it in one way or another. So the puzzles, I call them puzzles because it is some kind of game that we play. How do we solve these optimization problems in order to reach some multi-dimensional goals, not just cost, emissions, equity. It's really exciting, really difficult, but I have a really good team, so it's fun to play around and see all the technology that you guys are making and how they fit in.
Thank you. So we will be asking questions here in about 15, 20 minutes, so please be thinking about what you'd like to ask our panelists. Ben, what does the rise of EVs and renewables mean for communities moving forward? You just sort of started to touch on it, but would you expand?
Yeah, I think I did just start. It's energy independence, I think, is the best way to say it. Your car is not just your vehicle, it's a moving battery. And if you don't have to drive somewhere for some reason, that is now some asset that you could put on the same way you could put on your house on Airbnb for the weekend that you're not there. That car is now some distributed energy resource that could play a part in grid coordination. At the same time, the equity concern is how is everyone going to afford things like this? But in general, it is just completely game-changing all around.
Thank you. Michael?
Yeah, I think it's exciting to have the opportunity to not only have a vehicle that gets you around, but also it's kind of like this little power station. And really what I see with electric cars is it's going to be an integrated part of the grid going forward. It is a DER resource, and the technology is actually coming out sooner than later to start integrating that in. So you're thinking about a small microgrid, a community. When you look at the load profiles of this, and now you can start to see, hey, wait, someone bought a car here. And that's when we can start to reach out and say, do you want to integrate your electric car into the grid? Do you want to actually start to pull energy back off it in the times when renewables right now may not be producing? So it's an integral part, I think, electric cars. But the second half of that, too, is that, cities of the future, we also have to consider that some people may or may not have cars, right? And I think it goes back to, you brought up a great point, is that, maybe car ownership is something that's not as important in the future. Like, it goes back to my thoughts, is that we need to evolve the way that we use our resources, because really this is what it is. It's the thoughts of resources, and 20, 50, 100 years from now, we're going to be looking back and saying, wow, this was some interesting concepts we had. But it's an evolution of how we're consuming resources, but now it's bidirectional resources, just not electrons, right? It's a lot of different points to take up. So,
Phil?
Yeah, so, I agree with everything that was said. I think another area that we don't necessarily talk a lot about with EVs in particular is just how it's going to transform the local economy. As an example, you don't need the same mechanics that you had before, right? Because you got fewer parts, you just got the battery, you got the motor in there, you got the battery in there. And so some of the jobs that you would have had previously, you no longer require. Some of the real estate that was used previously for gas stations, you may no longer require. That's going to be repurposed. And so I think that's another aspect to it that we don't necessarily talk about in terms of how do some of these new technologies just change the topology of our local economies, et cetera. It's also the case that we spend a lot of time talking about carbon, what it's doing to the environment. Having EVs also just provides cleaner air for children who are near idling buses, school buses, and things like that. So reducing the amount of particulate matter in the air in our communities is super important too. And from a renewable standpoint, I think the exciting part of renewables is everything that was discussed in terms of distributed energy resources on homes and how do you coordinate those to solve grid issues, coordinate those for consumer benefit, and so on and so forth. So yeah, absolutely. I think it's a super exciting time.
Yeah, I think one of the things to add to that is, you think the city of the future, you might lose power to your local network at night. Your electric cars can now power it, right? Yeah. That's the level of integration we're going to get to, and the opportunities there is not only for it's changing our economy, but it's also changing the way that we live, which is huge, right?
Absolutely, and I think to bring up, your point, Michael, when you're talking about the rise of prosumers, right, and that we're going to have a far more bi-directional engagement with utilities in our communities. We're going to have more ownership of how we contribute to the grid as, solar becomes more prevalent in our communities as well. I know that there's opportunities to turn water heaters into batteries,
Oh, yeah.
as well as EVs and things like that, and that the homeowner can be more participatory
Yeah.
in these conversations. I think that's also really exciting. Um, I just got to unlock my phone, sorry. Um,
It's a key part of it, right?
it's a key part of it. But, it's not just about the physical infrastructure changes that need to happen too, right? There's a lot of modernization that needs to occur. What role does digital infrastructure play in all of this as well? Phil?
Yeah, so I think some of the stuff that you're probably working on, some of the stuff that your company's doing, ultimately digitalization, I think it works on two fronts. It's a consumer perspective, but then there's a utility perspective. I think from a consumer perspective, the low-hanging fruit is just using digital tools to create greater awareness of how you're consuming your energy in your home, how you're impacting the environment on a daily basis, giving you an opportunity to then make changes. So it provides, digitalization, I think, provides an opportunity for consumers to be more engaged in their energy consumption, which is a positive thing. I think you could debate and argue how many people are actually interested in that, how many people are only interested in perhaps saving money. But in any case, I think to the extent you're digitalizing these things, that you have an opportunity making that data available to consumers. From a utility perspective, I think there are a tremendous number of benefits to how utilities operate. So if I can have greater awareness of what's happening in my system at any given point in time, I can perhaps intervene in a way earlier or better, more efficiently, in a way that saves money for the utility, ultimately saves money for the consumers. So it all goes back to the consumers.
Great, thank you. Michael?
Yeah, I think data is the future, and for multiple reasons. I'll talk about on the utility side first. Is that a lot of the processing of data happens now. It's through an AMS system. It's centralized, and it's not on the point at a real time. I think really what's going to happen is that the grid actually digitizes is that information decisions can be kept on the edge. It's going to be kept on that transformer outside of your house, or it's going to be kept on that power line. And what's going to happen is that it's going to be a combination of multiple things that can dynamically reconfigure loads. It can actually do, flizzr or fault indication, reset, and it can probably do in the future something I call Plizzr, predictive, right? We need to also stop outages and predict weather and predict loads and load management. That's where data is going to be a huge component of this. And this is already in the works. There's multiple industries from, the big data houses to, manufacturers of equipment are all doing that. That's a huge part of this grid of the future. Second thing is on the prosumer side is that you can participate now. What a crazy concept. I could sign up with my Nest and I can save money. It's my choice, right? I could sign up hopefully in the future with my electric car and participate. We're giving the choice to participate into this grid of energy and control, which is what a revolutionary concept just in its own, right? Is that we're enabling the choice of joining the grid into a more controlled, integrated solution, which I only think is going to go further. Now you see it in your washer, you see it everywhere across the board. And that's the exciting part, is like, where can I save money and where can I actually reduce carbon footprint? And oh, by the way, I can help my neighbor out. So it's a different socioeconomic picture that we can paint now when I can actually help to give that back into the grid or consume it and use it at a later point. So it's everything. There's no real way to say anything other than that, is that the flow of information, digitization of how we consume, where we consume, when we consume, and how do we restructure how we actually transport all this resources is huge. So big opportunity, many levels.
Absolutely. Ben, you're on the forefront of some of these new things. What role does digital infrastructure play?
No, thank you. But honestly, they covered it really well. They hit all the points, which is what we're spending a lot of our time on. But I do want to just elaborate and connect both of them to the fact that when you do offer this digitalization of information, energy information, and you make it user-friendly and intuitive, you've demystified energy for people. And now people actually understand that they can have impact. Every light, like every switch that they have in their house has an impact. And when you demystify energy and you connect it to climate change, now people will feel and know that they are contributing every day or every moment that they choose a setting on their app, which connects to their home, which connects to the city of the future, and then the whole city is a player in lowering emissions or doing all these needed things for climate climate resilience.
You know, if I
Oh, go, Phil, you go first.
So if I just add one thing, I think that at least in this country, I think that the grid that delivers all this power is arguably the biggest thing that we take the most for granted. It's not only that it's delivering power, but you haven't given a second to thinking that this power might go out over the course of this panel right here. We just take that for granted. And that's a testament to systems that have been put in place to provide reliability and resiliency here. But because of that, people generally have zero awareness of it. It's just completely taken for granted. And so I'm excited about the opportunity potentially for that to change, because if we're not taking it for granted, it's less likely that we will be as inefficient with its consumption as we've been.
Yeah, one of the exciting things I see too is that, we talked about in earlier panels and other discussions is some of the socioeconomic challenges here, right? And, some of these communities where we could actually help them out is empowering them with, able to use, their consumption or limit their consumption. And I think that's empowerment also. If you give someone the ability to control resources at a fundamental level like that, it's part of this whole entire integration, right? And it goes back to, we have to give this prosumer perspective, not only for people who can deploy these, but these are resources that we can deploy in some of these communities, and it really helps, right? If you can lower, spending of money because we can be more efficient, well, that sounds like a win in some levels, right?
Absolutely, and I'm really glad we kind of touched on this, empowerment aspect of community engagement with, the rise of prosumers here and, their involvement in the energy transition. I think it ultimately adds to, and we haven't fully expanded on this yet, but like resilience, right, and the concepts of resilience within communities, especially as we face, growing challenges. Speaking of, what are some of these challenges, and can we dive in a little bit deeper, Michael?
So I think particularly with resilience is that the grid we're heading towards is bidirectional, right? So not only do we have large fossil fuel-based power sources, but now we have renewable-based, but also we have a flow of energy that's bidirectional. Resilience is really important in that because now it's fundamentally made the topology much more complex, right? So we're much more susceptible to failures. Philly brought up a good point. The lights might go off, right? We have to be ready for that. Now, how do we do that when, 60, 70% of our energy is renewable? So we have, we call that synthetic inertia that we have to spin up to get those electrons moving, right? So resilience goes back to part of the data is we need to have this predictive analysis. We should be able to tell, and we can tell it already, like, I turn on my Google Maps. It's like, hey, you've been here. Why don't you take it this way because you'll save 3%, right, in gas. I'm like, this is what the future of the grid's going to also, which is exciting, is the fact that predictive analytics and reconfiguration is part of this resilience. A storm rolling through 5 towns over should get the grid ready here, right? A storm that we actually know assets that were damaged can start to help roll out crews, or predictive asset damage. So that's really where the data is going, is that, through the measurement of the fundamentals of voltage, current, harmonics, phase angle, all those fun stuff, right, and temperature and weather, which I know you appreciate all that, is that we can actually put that into some of these more advanced algorithms, and it's actually happening now, right? Resilience is edge computing and edge data. And that's where we're going to start to transform this. Once we get that down, more and more, I think, integration of bidirectional power flow can happen. So,
Great, thank you. Ben?
Yeah, that's pretty much what's on my mind all the time, this transformation of the grid and the challenges. I think you can think of ChatGPT, that was just talked about a lot. It's a really big brain. That's one way to think about it. It's trained on a ton of data, so the resources it took was a lot of resources just to train this really big brain, and that brain is over and over and over again giving you these predictions, prompts, that are answers to your questions. The same thing's gonna have to happen with the grid, but the grid, when it's so complex, where one action of one house affects the whole system, affects every other house, just that one action that it takes to put a little power or take a little power affects the rest of the system. So if there's this kind of interconnected web where everyone is doing something and responding to something, you need this very big brain, this distributed intelligence, this network coordination that has never been done before. And you're gonna need little microgrid projects, maybe at universities or campuses, that can test some of these new ways of controlling, even without people in them, because it will backfire at the beginning. It's like half my code doesn't work ever. So it really is like a new challenge to coordinate in a modern way, but it's possible, and there's proof of that in a lot of other AI and technology.
You think we have most of the components, right? This is an integration problem.
Yeah.
Technology's there, right?
Yeah.
Bill, do you have anything to add?
Yeah, I mean, I would just underscore the reliability resiliency piece, especially given that we're talking about electrifying more parts of our economy. That raises the bar to the repercussions of failure. So if now your car is electrified and the grid doesn't work, not only do your lights not work, you can't get to work, right? That's different than the scenario that we're in today. And I would also add a potential challenge is around cybersecurity. I think that was talked about earlier. The more that we're digitalizing, the more stuff that we're putting into bits online. I mean, there's a risk there to attack. And I think when we talk about resiliency, thwarting cybersecurity attacks is a part of that. It's not just natural disasters. I mean, cybersecurity is something to consider too.
Thank you so much. And I have one more question for you all before we open it up to questions in the audience. So be thinking, because I am going to call on you. What is the most exciting thing to you on the horizon? Ben.
I'll go back to the naturalist side of things here. I would love to see coordination between resources and utilities that never had coordinated before. You'll still, for the near future, have some sort of gas-related piping around. Water will always be there, electricity. But these traditionally are not coordinating among each other. I would love to see this kind of unified coordination where we do act more like some sort of organism that grew together, understands each other, and that to me is the best way to roll out these crazy technologies and needed technologies for a city of the future.
Amazing, thank you. Phil.
Yeah, my answer is somewhat similar in that I think there's an opportunity, something we call behind the meter stuff in your home versus front of the meter, which is the grid. I think there's an opportunity for just better coordination of those two things. And when I was at Exelon is a company I was at previous to AES, there was something we were working on. We were working with this startup called Span. And if you haven't heard of them, it's pretty cool. It's basically, you have your breaker box in your basement that all your circuits run into. It's like a smart one of those, right? So it's like it's connected to everything in your home. You can control everything in your home through your phone or device or whatever. But it also has sort of revenue grade metering capabilities. So you can imagine a scenario where this same box that controls all the circuits in your home is also metering things in your home. Now you no longer need the utility meter. So now that opens up, well, is there an opportunity for utilities to integrate or own these new types of devices that also do these other functions within your home? So you have like a behind the meter device that's now also responsible for supporting other grid objectives that the utility has. And so I think it's in line with what you were saying, Ben. I think it's just this idea of a more closer integration between all the different pieces in the system.
Yeah, I want to add on to that. So that historically, utility industry has been very siloed between companies and partners and research. Is that those walls are starting to kind of get crumbled because this problem is just larger than one company. It's larger than one utility. It's larger than one university, right, or one government entry. So it's exciting to see the amount of collaboration just in industry as a whole, because everyone has value to add and value to extract from that. Now, how they define the value is different, right? It can be multiple ways, but that's the exciting part, is the collaboration. And people are getting on board with the fact is that I can add a small piece that has a huge impact. And so I really see that as exciting. And the second thing too is I see the rise of, and we had a great talk earlier about the intelligence we can apply, right? So that's exciting. So a lot of challenges, but a lot of potential. So.
Yeah, I think this is an incredibly exciting time to be involved in the energy sector as well as the smart cities, because a lot of these technologies are starting to really converge and to be able to apply them at scale, where we're going to see the real value and the real impact of what can be achieved from managing better resources management, whether that's better accessibility and resilience. I think we're just seeing the beginning of this next, city of the future, these limitless cities that come from these kinds of things. So thank you very much. Okay, now it's your turn. Yay, we have lots of questions. Love it. Okay, who's got the microphone? And let's go with you, right here in the front, ma'am. Uh-oh. There is not. Did you mind projecting? I'll repeat your question. Thank you.
I was wondering if you'd be able to touch on the role of larger scale battery systems in the city of the future. A couple years ago, I heard Fluence. Fluence is an AES Siemens company. I heard about a number of the projects they had, Los Angeles and others. We all know about the important role of battery storage in terms of helping to mitigate the intermittency of renewables. And just wanted to get your thoughts on the latest, greatest.
Yeah, so we love Fluence, obviously. We talk a lot about Fluence in the context of, this bigger category of non-wires alternatives, the NWAs, you hear them spoken as. And another challenge which we have it's not necessarily in the smart city context, but as we think about integrating renewables at utility scale, which is most of what we do, our ability to interconnect is a big challenge. The interconnection queues around the country are really long. It takes a long time to get our projects plugged up. And so there has been a lot of discussion about how do you use batteries as transmission assets, right? And so one of the main issues why the interconnection queues are so long is because they have to do all these congestion studies. We want to make sure that we're not maxing out the lines that are in question. So how do we use batteries as a means of absorbing some of that power at certain times when we're able, so that we can free up space on these lines so that we don't have to replace as many lines, and so that we can interconnect our projects faster. And so batteries are one of those. It's kind of like, you talk a lot about green hydrogen. Batteries are panacea for a lot of different things. But for us, the focus has been how can we leverage batteries to reduce congestion on transmission lines, to obviate the need for building more transmission so that we can interconnect our projects faster.
How about also for greater use of renewables?
Oh yeah, absolutely, right? So the more renewables that you're putting in the system, and you hit on it, you have all this intermittency, you have all this stuff. So batteries become that pressure valve for the system when it's needed. And so you're able to put more renewables on because batteries are there to support any potential congestion issues that you might have in your system.
Amazing, thank you. Okay, next question. We've got a gentleman in the back with a hat on.
Hi. Hello. Hello. Hi, I'm Tyler Weka. I'm an undergrad at GW. And one of my professors always says the future is distributed. Like you have a cell tower fall down and the other ones in the area can compensate, and like these new grids can. And my question is, in what cities or municipalities do you see the most opportunity for advancing the distributed energy resources? And what would be needed to expand it to more cities or maybe even suburbs in the future? Thank you.
Michael, Phil, or Ben?
You want to go first? Yeah, okay. Well, I think primarily we want to focus is where's the resource load the heaviest and what's the impact, right? You really need to do analysis of, as far as having the resilience to having an interconnected grid is you have to have the biggest payback because obviously the infrastructure is not, it's not cheap to do. So I would envision it to be in larger markets. It will progress out because it's naturally, as you solve those problems, the progression out into smaller, more rural electric grids will happen. But really where we could use it would be perfect examples like a city like New York or a city like DC where there's a lot of assets tied together, a lot of potential, and there's a lot of end users. So that's really where we should focus first.
Yeah. No, I'll agree and just expand a little bit. I think also any critical related infrastructure gets like first bid at that, partly because it's the last line of defense for a lot of these cities or municipalities. So I think that kind of gets the latest and greatest technology first. It should, just to keep the baseline of operation, and then everything else will someday become fully distributed.
Yeah, I was just going to add, just because maybe we haven't mentioned it, policy is a big piece of all this too. Like, I think as the point has been driven, all the technology is there, like, today to solve, like, most of the issues that we have. But there's all these other pesky questions around, like, who's going to pay for it, who's going to benefit from it, all those types of things. And so to the extent that there are cities that have policies that are friendly to these types of technologies coming on board, I mean, that's a big piece of it too.
Yeah, absolutely. I think IEEE has a couple of new standards that have come out to kind of help with best practices around the establishment of microgrids. And then I think too, like, not every city necessarily works in partnership with their utility. I think the structure of the utility is really important and what they can achieve within the municipality, and same thing for the municipality with what they can achieve with the utility, which is why I think having these mutual conversations or collaborative conversations is really important. So that way there can be maybe a unified vision moving forward with both entities working in tandem with each other. Great question. Next question. You, sir. Yes. Hold on. We're coming to you.
I'm Bob Hershey. I'm a consulting engineer. To what extent are you going to use digital twins in preparing some of the things you're talking about?
We have a digital twin in our lab right now. I think it's rolling out this, unlike ChatGPT, that can just put a warning. Some of the information might not be real. Don't take this as truth. This is a beta. This is a prototype. For the power grid, that is not, you can't say that. By the way, you might lose power. We haven't tested it fully. So digital twins for us is in between fully digital simulation, like full control, the ones and zeros that we can say this is kind of like reality. Then you get into one step before you get into control hardware in the loop or control digital twin, where just the control board is in this simulation environment, and then you make a little grid that is actually physical before it's on the full grid. So for us, it's part of the research process. And I think for many companies that want to validate and sell something that is convincing for something so critical like energy, you have to do it.
Yeah, it's a critical component to the overall structure. You have to have it to go forward. It's not only for the simulation side, but it's also, you have to understand that there's not assets deployed in every single point of the grid, right? So how do you do your load estimates? How do you do your load management? So the digital twin component of it's huge. You really can't do it without it. And I think there's multiple ways it's being deployed, not only in a simulation environment, but also when you don't have a resource, is how can you actually model it? So it fills in gaps to the model, but also fills into the potential of when you can build a digital twin asset simulation, it also allows you to understand where to deploy technologies and assets first. So there's multiple phases to the digital twin that's important, right? It's just not for simulation, it's just not for estimation, but it's also for the financial impacts of where can we make the grid more resilient by actually doing this modeling. So a lot of important parts of it, but you can't do it without it, it's the short answer.
And just so you know, for people who have other digital twin questions, I believe tomorrow we have a panel all about digital twins being applied. So please come back. Sir, I believe you had a question in the front?
Thinking about Ben's opening in New York City,
Yeah.
and what about a major plasma event happening? I mean, we're talking about something that's been 100 years in the past, but it's going to happen again.
Like a geomagnetic disturbance or a solar flare of some kind? Yeah. Yeah. So one of our lab members also looks into these kind of EMP, electromagnetic, like pulsing attacks that can be man-made. Someone can make a bomb like this. The sun. So thankfully NASA has like sun watchers, I want to call them, because they pay attention to to what's happening there. But no, it completely fries everything that we have right now. The person in our lab that mitigates against these kind of attacks mentions that there is very expensive insulation equipment that you can install. So maybe in the future where you do want to consider that a possibility, some of your critical infrastructure that's essential is heavily insulated. I'm talking like yeah. Apart from cyber attacks, the physical attacks that affect the cyber technology.
Yeah, I think coming from the sensor world, one of the NERC requirements that are coming up is you have to be able to measure DC and AC on these transmission lines. So the DC component is a big problem, obviously, as you get all these little charged particles hitting these conductors. So the good news is that I think people realize it's an issue. Yeah. So the bad news is there's been very little done. So
Yeah.
it is what it is, right? Just hope it points towards Mars, I guess.
So we have about 8 minutes left for questions, so we do have plenty of time. Okay. We've got one in the back, and then we'll, with the hat on, and then, there we go. Yeah, we've got a couple of hats in here. That's awesome.
I like my hat.
Okay.
I was wondering if everything's being distributed and disconnected and democratized, in other words, that begin with D, how would you roll out future changes, especially if the digital twin were to update and require, you know, a new set of information or a new formatting or a new file extension at least? How would you, if not enforce, then encourage, you know, everybody to update their standards, especially because maybe somebody bought into solar panel 1.0, but they don't want to upgrade to solar panel 2.0? How would you convince that and make it so that you don't have 100 microgrids running 100 different sets of software?
But that's what's going to happen anyways. I mean, you know, I think what the interesting part about this structure that you have to deploy here is that you're going to have assets of various revisions and levels, right? And what we're talking about when we bring the technology to the edge is the fact that the edge is part of the central computer, also the central AMS, central control in this cloud structure where, you know, it's okay to have different assets where are obsolete. And that's just going to be part of it. There's really no way around that. So when you're building these models, you're building these digital twins, is that you have to understand that that's a fact that you can't avoid, right? We're going to have transformers that are 70 plus years old in these substations. We're going to have assets of, like you said, solar 1.0. It's going to happen, but that's part of what you have to build into this infrastructure, right? So great question. I don't know what you guys think about that.
Yeah, I mean, I just think to the earlier point, I think to my opening point that you need to take a system approach to it, right? Because, you know, Mike's absolutely right, but everything that happens everywhere in this future world, we're not completely islanded where we're not connected. We're still connected. The grid still exists, but everything that happens does have impacts on other parts of the system. And so to the extent we're able to take a system approach as we're designing this system of the future, that's helpful. I mean, back to the comment about policy. Like these are all the other things. Like we spend a lot of time talking about the technology and because it's really cool, but the policy matters too. Who's governing? What are the rules of the road for how all this stuff works together as well? You have all these different aggregators coming in the system. You've got Tesla in the mix, and you've got all these different folks in there, the EV companies, all these different players. You know, who's managing all of that? So that's another part of it.
Amazing. Okay, we have time for one more question. Down here in the front, please. Right there. Awesome.
Thank you. Just a little background, power systems engineer working towards holistic solution, which is what we're working towards. By the way, what a panel you have.
They did great.
Holistic solution from the home washer, like you said, all the way to the nuclear power plant in between. And the challenges you all talked about, the systems, the software, the people doing different things, the current infrastructure. Very quickly, think about the internet, the telephones going from landlines to power lines. Don't you think, or what do you think? What do you think about the need to redesign our grid, not to allow ourselves to just slowly nibble upon these technical and technological solutions? We talked about microgrids or building a grid of microgrids. It seems to me that if we don't do that and include policy and regulatory to guide us to do this, we will find that we've spent a lot of money in the next 5 years. And we know we have a lot of time. It's going to take 10 years to do this. So I'm curious about your expert opinion and how do you feel the right approach to do this properly for our children?
Thank you. It was a big question, but
Yeah.
I mean, it's all on you, Ben.
Go, Ben. You got this.
That's the question I think that I have that I would have asked this panel too. No, but I'll say that like the collaboration between companies and groups that hadn't collaborated before, that you have to be willing to, like the power grid company has to collaborate with like just data processing and data people, same as policy people and equity people. Like it's no longer this like one company is going to solve it. So my only answer is just much more collaboration that you have not had before, that you didn't even think you needed. I think that's the way.
Yeah, I mean, I think I also don't have an answer. I think that's an excellent question. I think if you throw also on top of that the challenge that we've got 50 different states in the U.S., and then within that you've got different utility jurisdictions, and within that you've got all these different stakeholders. It's almost impossible to imagine that we're going to actually do it the right way, which is, I think, as you say, sort of starting over in some places. I know at one time Google had Sidewalk Labs, and they were doing some stuff up in Canada, trying to do something like that. I think they ended up shutting it down. But that's the right kind of, thinking, I think.
Fusion.
There it is.
We need to solve the problem. We're close, right? Like we're only 40, 50 years out. But yeah, I think we're probably not going to do it right. We're just going to roll out parts of it. It's going to be a little bit of a mess, but over time we'll get cleaned up. You can't do it all at once anyways, right? So it's the nature of the beast, and it's the problems that we're solving, right? It's going to be, yeah, you said it, it's going to be fun.